All right, now that we have pulled apart our problem and really gone into the different types of triangles, how you name them, let's answer a few questions before we really go into answering this question. Let's explore naming triangles further. All right, so let's look at number 13 here. It says, look at triangle A. Triangle A. How many sides are the same length? Well, they've measured these sides for us. So this should be very easy for us to determine. Let's look. There's 3 sides to every triangle. This side is 8 inches, this side is 8 inches, and this side is 8 inches. So how many of those sides are the same length? What do you think? Hopefully you said that 3 of the sides are the same length. All right. What kinds of angles does it have? All right, well, let's see. Here's an angle. Let me identify these angles for you just in case you're still having a hard time looking at the angles on a triangle. So here's an angle, and here's an angle. All right. What types of angles are those? Think about what you know. Anytime an angle is less than 90 degrees, it's acute. If it's exactly 90 degrees, it's a right. And if it's more than 90 degrees, it's obtuse. What do you think these look like? Hopefully, you have identified these angles as being acute. Sorry, it's very hard to write with the pen on the laptop, so it's going to be a little bit sloppy. But, all right, so these are acute. So what are the 2 names for this triangle? We know that we can name a triangle based on its angles and based on its side. There are 2 names for every triangle. You can put them together, okay? So if a triangle has 3 sides that are the same length, what do you call that? What do you call that type of triangle? We said that all 3 sides of the triangle are the same length. And what do we know about a triangle that has 3 equal sides? If all 3 sides are the same length, that means all 3 sides are equal. If all 3 sides are equal, it's a equilateral triangle. All right, so that's one name. Now, what kind of angles does it have? All 3 of these angles were what? They were acute. So what do we know about a triangle that has all acute angles? There were 3 angles, all 3 were acute. 3 acute angles, it's an acute triangle. So what are the 2 names for this triangle? Well, we know that it can be called an acute, ooh, sloppy, sloppy, equilateral. All right. This is pretty bad, guys. Sorry. All right. So, what are the 2 names for triangle B? Let's identify those angles and sides. What are the 2 names for triangle B? Well, let's look at the angles first. Here's an angle, here's an angle, here's an angle. What type of angles are these? This guy and this guy. What type of angles are those? Oh, they're so little. They're acute, right? Little things are acute. And what about this guy here? Oh, he looks pretty big and spread out. If I took a Post-it note corner and put it in there, that would definitely be greater than the corner of a Post-it note. So that means that he's obtuse. So what do we know about a triangle that has an obtuse angle? anytime that a triangle has an obtuse angle, it's an obtuse triangle. So we know that we could name this as an obtuse triangle. Let's look at the sides. One side's 9 inches, one side's 7 inches, and one side's 14 inches. Are any of those sides the same? No, none of them are. So we should know that if we have no equal sides, it's a scalene triangle. So this triangle here could be called obtuse scalene, right? Can this triangle also be called an acute triangle? Why or why not? Can we call this, it's got 2 acute angles. Can we call it an acute triangle? No, because an acute triangle has to have 3 acute angles, and this only has 2 acute angles. Let's look at number 15. What are the 2 names for triangle C? All right, let's look at triangle C here. Well, let's look at the angles first. I see 3 angles, as I should, because it's a triangle. All triangles have 3 angles. And let's identify those angles. Well, what do you think about this angle here? Do you think it might be a right triangle? Let's test it. If you are not sure, let's test it. All right? If this was a post-it note, let's test whether this triangle is a right triangle. I'm going to take this square, I'm going to slip it right in there. Oh, that lines up pretty nice, don't you think? So if this square fits right in there like that, what do you think? I'd say that's a right angle, wouldn't you? All right. What about these other angles here? What about this guy and this guy? They look pretty small, right? I'd say they are definitely less than 90 degrees. So we've got 2 acute angles and a single right angle. What do we know about a triangle that has a single right angle? It's a right triangle. Okay, so we know that we can call this guy a right triangle, but let's look at the lengths. Let me move this out of the way here. Go away, square. All right, let's look at the lengths of our sides, because we know that we can name it based on that as well. Well, let's see, I've got a 12-inch side, a 12-inch side, and then I've got a 17-inch side. Oh, 2 of the sides are the same and 1 is different. What do we know about that? What do we know about triangles that have 2 sides that are the same, 2 sides that are equal? 2 equal sides is an isosceles triangle. So we could call this guy a right isosceles, all right? So explain how to give a complete description of the triangle. Well, first, you want to look at the angles and decide what type of triangle it is based on those angles. Then you want to look at its sides and figure out what type of triangle it is based on the sides, and then you put those 2 words together. All right, so we could have an acute equilateral. We have, in this case, we have an obtuse scalene and a right isosceles, but they can be put together in other ways. Okay, you can also have a right isosceles or an obtuse isosceles. You could also have some other combinations. All right. So we've pulled that apart. Now it is time for you to actually answer the question. So on the next slide, you are going to be actually answering the question yourself. Good luck.